Hey guys, today we're going to do a video on algebra with the distributive property. And all that means is remember we have a bracket and some polynomial or some constant term in front of it, okay? So I'll just remind you that the distributive property simply says that whenever we have a polynomial or in this case just a constant term in front of a bracket, it multiplies every term inside the bracket individually, okay? So if we go ahead and multiply through to simplify our equation, we're going to get 7 times 3x, which provides us with 21x, okay? And then we'll have 7 times negative 4, or minus 4 times 7, if you'd rather think of it that way. And either way, we'll have minus 28. On the other side, we simply have a linear polynomial. And so now, if we want to solve this equation for x, we have to get all of the x terms in the same sign equal sign. Okay, actually right there. And so you can pick your side. I'm going to choose to move the x's onto the left side simply because the 21x is greater than 15x, and I like to have my x terms being positive. If we were to subtract 21x from both sides, the x term would become negative over here. I'd rather keep it positive. Okay. And so, just like we always have with algebra, we're going to subtract 15x to make it go away on the right side, and we always do the same thing on both sides. And so we'll subtract 15x over here as well. That brings us down to 21x minus 15x. We're combining like terms, both x terms, and so we can put them together. And so we'll have 6x minus 28 is now equal to simply 8, right? And 15x is 1 away. And now we're back to step 2 algebraic equation. We want to isolate the term with the variable. And so we're going to move over this term onto the right side. So if you want to get rid of minus 28, we think of the inverse operation once again. What is the inverse of subtracting 28? Clearly adding 28. And we always do the same thing on both sides. And so they go away. And so we end up with 6x equals 36. And if 6 times x is equal to 36, we're still looking for the value of x. And so how do we get rid of the multiplication by 6? We think of the inverse operation, which is dividing by 6. We always do the same thing on both sides. The 6's cancel out nicely. And so we're left with our solution. X is equal to 36 divided by 6 equals 6. Okay. So example 2 is a tiny bit messier, but it's the same kind of ideas that we're going to apply to it to solve it. Okay. So first off, we're going to multiply through with the distributive property. So again, the 2x is in front of the bracket, and so it multiplies each term inside the bracket one at a time. So 2x times 3x, remembering our exponent laws, gives us 5x squared, right? Because x times itself becomes x squared. Next, 2x times minus 2 brings us negative 4x, and then minus 7 is equal to 3x squared minus 4x plus 11. I'm going to work with the 3x squared terms first. So I like to get the x squared term positive on whichever side I'm going to work with. And since it's greater on the left than it is on the right, I'm going to subtract 3x squared from both sides so that it ends up positive on the left. Okay? So since we have 3x squared on the right side and we want to move it over to the left side, we could simply subtract 3x squared. That will get rid of it. And we always do the same thing on both sides, as always. And so now we're combining like terms again. You have x squared in both terms, so we can combine them. 5 minus 3 means that we have, excuse me, we have 2x squared minus 4x minus 7 is now equal to negative 4x plus 11 because the 3x squared was canceled out. Now we can work with the x term, right? We want to move them all on one side. Now this is going to be a little bit of a funny situation because we have negative 4x here as well as on the left side. And so I'm going to pick and choose one side. You can kind of choose whichever way you'd rather. But I'm going to add 4x on this side to cancel it out. But what happens is when we do the same thing on the other side, if we add 4x on the left side, we see that it also gets rid of the negative 4x here, because negative 4x and positive 4x simply get rid of one another, okay? And so they're actually going to completely go away, and we will no longer have any x terms, okay? And so now we'll have 2x squared, still minus 7, is equal to, the negative 4x is gone, so all we have left on the right side is 11, and now we're actually pretty close to a simple two-step algebra equation. Okay? We want to isolate our variable. Here, and there are many ways to solve these equations when it comes down to an x squared equation. For those of you that are familiar with quadratics, you might see a few different ways. I'm going to show you what I think to be the most straightforward way. So I'm going to isolate the x squared term on one side. So I want to get rid of the minus 7, thus adding 7 on both sides. That will get rid of the minus 7. Inverse operations always cancel each other out. And so we have 2x squared is equal to 11 plus 7 is 18. Now, we want to isolate the x squared, so we want to get rid of the 2 in front. What's the inverse of multiplying by 2? Clearly that's dividing by 2. And we always do the same thing on both sides, so the 2's cancel out. Let's finish that off over here. So with the 2's canceled out, we have x squared is equal to 18 divided by 2 is 9. And now we have x squared is equal to 9. We'd like to have a solution just for x. And so we think, what's the inverse of squaring x? That's the square root. And so we take the square root for both sides. And remember, the square root of 9 can be positive 3, or it can be negative 3, since two negatives multiplied together still create a positive product. And so for our solution, we'll have x is equal to positive or negative 3. Okay? I hope that helps. I hope that helps you guys become a bit more familiar and comfortable using the distributive property, multiplying through any brackets that kind of come along. With the second example, there are many different ways to solve towards the last few steps. This is just kind of what I would go with. So I hope that helps. If you guys have any questions, comments, suggestions, please leave a comment and request for future videos. As always, let me know, and thanks for watching.